Hi, this is Miss Triangle. This is our last section in Chapter 2, 2.6. Works on flowchart proofs and paragraph proofs, so just two different types of proofs. So make sure you're starting by putting the date in the title in the top right corner of your notes or the top of your notes somewhere. All right, then our essential question, set up your lines for your Cornell notes. Your essential question: how can we use flowchart and paragraph proofs to prove geometric relationships? So we've talked about algebraic proofs. We've talked about two-column proofs with the statement and reasons. In this section, we'll work on two new types of proofs. So we're on learning target, or LT2F. I can write a flowchart or a paragraph proof to prove geometric relationships. Then I'm going to go over the vocab. So flowchart proof. It looks like a flowchart. So it uses boxes and arrows to show the flow of a logical argument. And I kind of showed you an example. These would be filled in, but it has like little circles and rectangles and arrows. So it's a flowchart proof. Paragraph proof, just like it sounds, you're basically writing it out in words. So you're using sentences to write it out, and depending on the problem and the proof of what you're being asked to prove, sometimes a two-column proof will be best, sometimes a flowchart, sometimes a paragraph will actually be easiest. So that's why we teach you all three, so that you have those tools available to you. So pause the video if you need more time. I'm going to All right, we have several vocabulary words today. So the expectation is that you write the vocab word down and that you write something. You can always paraphrase, abbreviate, summarize. So right angle congruence theorem, what is that? Basically that all right angles are congruent because they are all 90 degrees. So if angle A is 90 degrees and angle B is 90 degrees, then you can say that angle A is congruent to angle B using the right angle congruence theorem. All right, then our next vocabulary word is the congruent supplements theorem. So again, you do not have to write everything, okay? Here is a good summary as well. If angle 1 and 2 are supplementary, if angle 3 and 2 are supplementary, then 1 and 3 are also supplementary. Or you could draw a picture if you're more of a visual person. So let's say angle 1 and 2 are supplementary, 60 and 120. Remember, supplementary, it adds up to 180. Okay, and let's say angle 2 and angle 3 are supplementary, 60 and 120. Then angle 1 is congruent to angle 3, 60 and 60. Okay, so that's what that theorem is saying. The congruent complements theorem is basically the same thing, except remember complementary angles add to 90. So it's saying if angle 4 and 5 are complementary, so let's make something up, like maybe 40 and 50 degrees, that's complementary, and angle 6 and 5 are complementary, then angle 4 and 6 are congruent. They're both 40. So write down what you need to. Pause the video if you need more time. So you should have something written for all three of these. Again, you don't have to copy this whole paragraph word for word. A picture would work, abbreviation, a summary would work. All right, whoops. Let's make this a little bigger. All right, we've got a couple more theorems, vocab. So we have the linear pair. So remember, that means angles that add up to 180. That's what a linear pair is. Linear is a line. So if two angles form a linear pair, they are supplementary. So if this is 150, if angle 1 is 150 and angle 2 is 30, then they are supplementary. Okay, so this is a good summary, or the picture would also work. All right, the last, I believe, theorem or vocab is the vertical angle congruence theorem, and that's pretty short and sweet. Vertical angles are congruent. Remember, vertical angles are across in the x diagram. So angle 1, let's say that's 30, and angle 3. Those are congruent because they are vertical. Angle 1 and angle 3 are vertical. On the same side, angle 2 and angle 4 are also vertical and congruent. And remember, adjacent angles, since they are on a line, are supplementary. So pause the video if you need any more time for this. All right, and we're going to get into the examples. So you are going to need to write down example 1. So pause the video so that you can copy the 2-column proof. You definitely do need this part. Given angle 1 and angle 2 are right angles, prove that angle 1 is congruent to angle 2. And you do need this 2-column proof. So pause the video so that you can write that down. Okay, so just to kind of get you used to a flowchart proof, what we're going to do for this example is we're going to take a 2-column proof. So up here it's a 2-column proof with my statements and my reasons, and we're not going to work on coming up with the proof, we're just going to convert it into a flowchart proof. So just like any proof, you start with what's given to you. So I start with the first line, angle 1 and angle 2 are right angles. I'm going to go ahead and start with that. So angle 1 and angle 2 are right angles. Oops, right angles. I'm going to put that in a little bubble. And my reason, I kind of put the reason underneath. The reason is given right here. That was given. All right, then I kind of draw an arrow as I go to the next thing, which is that angle 1 is 90 and angle 2 are 90, so that's next. Measure of angle 1 equals 90. Measure of angle 2 is also 90. Put that in a little box. My reason, definition of a right angle. Okay. Then I'm going to come over here. I'm going to do my next line, angle 1 equals angle 2. And my reason is going to be the transitive property. And then lastly, I have that angle 1 is congruent to angle 2. And my reason is the definition of congruent angles. Okay. So if you need more time, pause it. So that's kind of what a flowchart proof looks like. Some people really like them. To me, they're a little hard to follow. I kind of prefer the 2-column myself, but it just kind of depends on what you're doing. All right, here is example 2. So we're going to do the same thing. We're going to use the given 2-column proof to write a flowchart proof that proves that 2 angles supplementary to the same angle are congruent. So let's write down the given part and the proof part, and then we'll just do the flowchart proof for this one. So given, angle 1 and angle 2 are supplementary. So right here, these two are supplementary. Angle 3 and angle 2 are also supplementary. So prove that angle 1 is congruent to angle 3. All right, so let's start with this first part right here. So I'm going to go ahead and write that out. Angle 1 and angle 2 are supplementary. Angle 3 and angle 2 are also supplementary. My reason is given. So we're done with that line. All right. Then I'm going to kind of just split this up. I'm going to split this line up into 2 right here. So I'm going to say that measure of angle 1 plus the measure of angle 2 equals 180 degrees. And I'm going to say the measure of angle 3 plus the measure of angle 2 is also 180 degrees. Okay, and my reason is going to be the definition of supplementary angles. Definition of supplementary angles. All right. Then what? Then I'm going to combine these into this line. Angle 1 plus angle 2 equals, so the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. Okay, my reason is the transitive property. All right, then let's go to this one. Measure of angle 1 equals the measure of angle 3. And my reason is going to be subtraction property. So basically what I did, whoops, I forgot angle 1 right there, is I subtracted angle 2 from each side. So I subtracted out this and this. Right. And then lastly, angle 1 is congruent to angle 3. So that's this line, and my reason is the definition of, I'm running out of room, congruent angles. So I'll kind of pause this. If you need more time for example 2, you can pause the video. I'm going to go on to example 3.